Hello everyone, in this tutorial I will explain how RAG works and also I'll explain terms like token, embedding, vector database. I created a visual here to show you examples so it's easy for you to understand how this process works and explain to you also all these terms. So let's get started. First, let me explain to you quickly what's RAG before we go through the whole process. RAG stands for Retrieval Augmented Generation. In a simple term, it's mean that you have a document or multiple documents and you want to find informations inside all these documents. That's what RAG is, finding informations based on your questions. Okay, so how the RAG system works. So the process will start with having a document, and this document contain information in raw text or in any other formats. Here we have a document and it's contain just a piece of text here with 3 lines of raw text. The second step here is we need to take this document and we need to split the text into different chunks. Okay, so to do that, we will use a tool called text splitter. And this tool will take the piece of text and break it down into different pieces of text. It's called chunks. So in our example here, we have this text and we break it down to 3 different chunks. And each chunks is different from the other one. So here the first chunks take the first sentence, the second chunks take the second sentence, and the third one took the third sentence. So that's basically what is the text splitter. But there's 2 important things here, chunk size and chunk overlap. And what they are mean. First, let's explain the chunk size. The chunk size basically how many words we need in each chunks. So for example, if we put 5 words, it will take this piece of text and it will split it by 5 words each. So here, for example, it will be 5 words. Here it also will be 5, and here it will be 5. So this is basically what chunk size mean. And of course, this number will be much bigger. It could be like 100, 200, or even more. It's really depend on what you need to use it for. So the bigger the chunk size is, the bigger you will have context inside each chunks. And that could play a bigger role if you're designing chatbot, for example, to give you a summary. So you need more context in each chunk. The AI will be able to give you more chunks when returning informations. If you're designing, for example, a chatbot customer support, smaller chunks will be better because each chunk will contain small informations. So when retrieve the questions, the answer will be precise. So that's basically what the chunk size is. And the second thing is the chunks overlap. Chunks overlap is how many words are overlapping between each chunks. And to explain it here, I have another example. In this example, we have 2 chunks. And as you see, the first chunks, it has a text and it's end up with patterns. The second chunks is started with in wither patterns. So in this case, we have a chunk overlap with 3 words. So the 3 words of chunks 1 is basically overlapping in chunks 2, and so on for all other chunks. The important rule here is the AI will maintain context between each chunks. When you ask a questions later on to retrieve information, the AI will not lose the context because we added here this overlap words, and this overlap words will maintain the context between the chunks 1 and chunks 2 and chunks 3. So for example, in chunks 3, we will start with this last 3 words. And in chunks 4, we'll take the last 3 words and we will start it with the first 3 words in chunks 4. So on. So that's really important to maintain the context. So AI will understand the relations between each chunks. So when it starts giving you an answer, it's not going to hallucinate and the quality of the answer will be much better. So that's what is a chunk size is and the chunks overlap. So let's revisit what we did so far. We took the document and we split it to 3 different chunks. What we will do next is we will tokenizing each chunks. Before we explaining what is tokenizing mean, let me first explain what is tokens. So tokens is considered word or a subword or even a sample. Okay, so for example, here we have artificial intelligence is transforming industry, and there is a dot at the end, right? If we break this text here to tokens, then artificial will consider a token, intelligent will consider a token, is consider a token, transforming consider a token, and so on. And if you see here also, it take the dot and consider it as a token. Some other model might consider also subwords, so intelligence break down into two words, and each one of them will consider as a token. This is what token is. It's basically a word or a subword or a symbol. Now, what is tokenizing mean? Tokenizing, basically we taking this whole text and we convert it to tokens. So as you see here, this text converted to tokens, and this text converted to tokens. Also, this text converted to tokens. So tokenizing is split each sentence into individual tokens. Revisiting what we did so far, we take the document, we split it into different chunks. We define the chunk size, so each size of chunks will be equal, and we'll also define the chunks overlap. So we define how many tokens that's going to be overlap between each chunks. And then after that, we converting each chunks into tokens. Next, what we will need to do is take these tokens and convert it to vectors. And vectors basically in a simple term is a numbers representing each token. So here artificial is token, but if we convert it to vector, it will look like this number. Intelligent as well will look like this, is will look like this, and so on. So basically vector is a number representing each token, but you might wondering why we need to convert each token to vectors. Why we not just use these tokens? The reason of that is the computer doesn't really understand what text mean. It understands numbers. That's why it's very important to convert this token to numbers. Okay, so for now, we took the tokens and we converted to vectors. And each token has different vectors representing only this token. And the closest the number is, the more similar the word is. For example, here, if we take two words that they are similar to each other's, you'll see that these numbers are very much closer. And if you take two words that's very different to each other, you'll see that the number is very much different. So for example, is here and n, they are very close to each other in vectors. And the reason they are very close because they used in grammars and they tend to be in the same context. So that is what vector mean. It's a number representing each token, and this vector is used by machine learning to determine each word's mean and how each word related to the other word. The much more closer these numbers to other numbers, meaning that this tokens is more closer meaning to the other token. After that, we will get the average vector per chunks. There are different methods used to give you a sentence vectors. So basically this numbers here for the whole chunks. So this vectors, it's only related to this chunks. It captures the meaning of the chunks. It take in consideration each word order. If we take this word intelligence and we switch places, then the vectors here will look different because now the meaning have changed and it's no longer means the same as the first sentence. So that's why this numbers is only representing the chunks with the same order it has. So now we got this vectors for the whole chunks. So just note here, from tokenizing each chunks, this whole process called embedding. So embedding is converting the chunks to token, and this token will be converted to vector, and this vectors will be average to the whole chunks. This process called embedding. We use models for embeddings like, for example, OpenAI. It has a text embedding models, and this model will basically take all the chunks and then it's going to convert it to vectors and give you vectors per each chunks. It won't give you the vectors per each word. It will give you the vectors per each chunk of text. Then we're going to take these vectors that we got from OpenAI and we're going to store them in a vector database. And there's a multiple vector database out there, but one of the very popular is Pinecone vector database. So we will send these vectors to Pinecone vector database. It will look like this. It will contain a metadata about the document and the text and the vectors related to this text. So for each chunks here, we have a vector representing this whole chunks, and it's stored in index inside Pinecone. So the index will have all these chunks, and each chunks contain the metadata about the vectors and what text related to this vector and what is the source document. After we take our document and then we convert it to vectors for each chunk, and we store these vectors inside a vector database. Now what's gonna happen when we need to retrieve this related informations from the database? Let's say you ask questions related to the document. For example, you ask how AI used in industry. You send this information. OpenAI will take these questions and it will also convert it to vectors, right? Because it needs to understand the meaning of this question. So when you search the database, you will use these vectors to find the similar numbers related to this questions here. And the similar number is mean this is numbers is more related to this question. So probably the answer will be in these numbers. The more closer the number is in the vector database to this query, the high possibility that the answer will be in this number. We converted this text here to a vector. Now we going to search for the similar vectors inside the Pinecone database. So which vectors is close to these vectors here? We will use vector retrieval to retrieve all the chunks that's related to the questions. Here, for example, it's retrieved one chunks, and here's a text of the chunks. It also gives you a score. This score is how close this chunks from the user query. And 0.85, it's really high number. This means that this text is really related to the user questions. And you basically can define how many chunks it's need to retrieve. And here we can have multiple chunks, and each chunks will have a different score number. It basically sort from the highest to the lowest. Highest mean the most related to the user questions, and lowest is less related to user questions. And the score is basically tell that the chunks is related or not related to the user questions. After we retrieve the chunks with the score here, then we will use the AI and we will give the AI all return chunks. Like here we have one chunks, but if we have 5, we will give the AI all 5 chunks, and the AI will use models like, for example, GPT-4o to process all these chunks with the user question, and it will take all this information, give you a final response. There is an important thing here is a prompt. The prompt is what you define to the AI to tell it what the answer should look like. So for example, if you tell the AI give the answer in a summary or in a bullet point, that's what's going to happen. The AI will take this in consideration when it gives you the final answer. The AI will take each chunks, evaluate it, find the relative information inside each chunk, and it will look at the prompt you give the AI, and based on the prompt, and the information that it's returned from the vector database, the AI will process all this and return the answers to you. This is what RAG is and how it work together to give you the answer. Well, let's revisit of what we explained. We have the document and we took this document, split it into different chunks, and we use OpenAI embedding models that will tokenize each chunks into tokens, and it converted to vector and give you an average vector representing each chunks in the document. We're going to take these vectors that returned from OpenAI. We will store it into vector database. We can use any vector database. These vectors will be stored into something called index. It will look like this. It contains metadata about the text, document, and the vectors that we retrieve from the embedding models. When user asks questions, it will use the embedding model to convert this question into vector, and it will search inside the Pinecone vector database to get the most closer vectors to the user questions. It will return the chunks that's high relative to the user question. Could be 1 chunks, could be 5. You can define how many chunks return. These chunks, along with the user question and the prompt, will be taken to the OpenAI model to process them all to give you a response that's related to the user questions. I hope you understand what is RAG and how it works, and all these technical terms, what they mean and how they work together to serve the RAG. If you want to do a project to understand more in practice how this process works, in my previous video I have a project where we have N8N, one of the automation tool. We created a RAG system where we insert a document into Pinecone and then we later retrieve it using a chat model. Please check out my video in the descriptions if you want to apply this into a project. Thank you so much for watching.